They're never going to run into each other. This here and here, those are parallel segments. These are parallel segments, so on and so forth. Intersecting lines are in the same place, but they will touch in exactly one point. So for example, this segment here, they're intersecting right there. And again, no matter how far I extended those lines out, they would still just be intersecting in this one point here. The same with this back here and this here. They're intersecting in this one point right here. Perpendicular lines, still intersecting lines, but they just intersect in a special way at exactly 90 degrees. I don't know if there are any examples of that right here, the way this figure actually is. There would be some perpendicular intersecting lines if we drew in the apothem like we did back in chapter 10. Skew lines are the ones that maybe you haven't heard of yet. They're kind of neither of these. So they're not in the same plane, so they're not going to ever touch each other, so they never intersect. But even though they will never touch each other, they're not considered parallel because they're not in the same plane. So for example, if I looked at this segment right here and this right here, well, they're never going to touch in any way, but they're not in the same plane, so I can't really consider them parallel. If I looked at this right here and this up here, those are skew. So I think when you're looking for skew lines in a figure like this, you want to think two things, different planes, different directions. That's probably your key, that they're skew. Okay. We're going to be getting into the idea of lines cut by a transversal. That's going to create a lot of angle pairs that we're going to use from here on out. So a transversal is just a line that intersects two or more coplanar lines. So again, I have two lines here that will be on the same plane. This is the transversal, okay, because this transversal is intersecting both lines. I could have, you know, an infinite number of lines going this way, and this one transversal would still be intersecting all of them. You want to get used to the words interior and exterior. Interior is just the space between the lines that I'm talking about, and exterior is the space, it would be up here and also down here. Exterior is just the space outside the lines that I'm talking about. So we're going to get into some angle pairs, and they're named based on their location. So you're looking at whether or not they're interior or exterior, are the angles themselves between the two lines or outside the lines, and where are they relative to the transversal. Okay, so here is the first set, alternate interior and alternate exterior. So again, hopefully you can see the shading at least to some degree. But if I look at angles 1 and 2, angle 1 and 2, again, if I kind of highlight where those angles are, this line that both of those angles are sharing is the transversal. So you have to share a transversal, otherwise you don't have a relationship of any kind. So here's my transversal. Angle 1 is on the left side of the transversal. Angle 2 is on the right side of the transversal. But both of these angles are in the interior. They're between the two lines that are creating them, so to speak. So different sides of the transversal, both interior. That's how I get the name alternate interior. Alternate exterior, again, if I'm looking at angle 1 and 2, and I kind of highlight those, this shared piece is the transversal. These are the lines that are creating the angles with the transversal, but I could see angle 1 is out here, angle 2 is out here. Same with angle 3 and angle 4. So again, these angle pairs, still different sides of the transversal, because 1 is on the left, 2 is on the right, 3 is on the right, 4 is on the left, but they're both exterior, they're both outside the lines. So alternate interior and exterior angles. A lot of people remember the letter Z, because no matter how I draw in the Z, if I use the line, the transversal, and the other line, somehow I'm going to get something that looks like the letter Z. Okay, the next set are same side interior and same side exterior. So if I look at angle 1 and 2, Okay, here, again, I'm sort of marking where these angles are. The piece that they both share is the transversal. That's how I can distinguish the transversal. It's that shared line. The other lines are the lines that are creating the angles. So if I look at angle 1 and 2, they're both on the left side of the transversal, same side of the transversal, and they're both between the lines. So since they're on the same side of the transversal and between the lines, that's how I get the name same side interior. Again, the name comes from position on the transversal and whether or not they're between the lines or outside the lines. Same side exterior. Okay, so the orientation of this is a little bit different, but if I look at angle 1 and angle 2, the first thing I do is I find the line that they both share, which is this one right here. So that is my transversal in this case, that shared line. The other lines that are creating the angles help make up my interior. So if I look at angle 1 and angle 2, they're both on the same side of the transversal. Again, maybe this time I'm looking at it like they're on top of the transversal, above the transversal, but they're both outside the lines. Same with angle 3 and angle 4. This time they're both kind of underneath the transversal, but still on the same side of the transversal, both outside the lines. So that's how I get the name same side exterior angles. The last angle pair are called corresponding angles. So corresponding basically means the same position. There's quite a lot of pairs of these. Okay, so corresponding angles, they're on the same side of the transversal, but one angle is between the lines and one is outside the lines. Okay, so again, that sort of you have to think of that idea of same position. So if I look at angle 1 and angle 2, again, here's the shared piece. That makes that the transversal for that angle pair. And if I look at the lines that help create those angles, this is the space between the lines, so that's the interior. So if I look at these, they're both sort of sitting on top of the transversal and kind of to the left of the two lines, if you want to think about it that way. But they're in the same position. Same with angle 3 and angle 4. Angle 5 and angle 6 are in the same position. They're both, depending on how you're looking at it, kind of hanging from the transversal or underneath the transversal. And both kind of to the left of the line that creates them. Again, however you kind of think about it. But the reason why this is named, you'll notice corresponding angles don't ever use the words interior or exterior. That's because you cannot put those words with this angle pair, because in corresponding angles, one angle is going to be interior and one angle is going to be exterior. Okay? Again, it's all about same position. Those are the angle pairs that are created when lines are cut by a transversal, no matter what. But when you're given that the lines that are creating the angles are parallel, now these angle pairs actually have a relationship. So anytime lines are cut by a transversal, you have alternate interior, alternate exterior, and corresponding angles. But if the lines are parallel, then those angle pairs are actually congruent to each other. And you can use that relationship to solve for some variables and figure out some angle measures. Anytime you have lines cut by a transversal, you will have same side interior and same side exterior angles. But again, when you're given that those lines are parallel, then these same side interior and exterior angles end up being supplementary. So the best way that people tend to use that is same side supplementary. Your angle pairs that are starting with S are supplementary. The other ones are congruent. Then just because we're going into figures, trying to set up equations to solve for variables, you still want to remember that vertical angles are always congruent and linear pairs are always supplementary. You do not need to be given that lines are parallel. You don't need to be given any other kind of information to know that. That just exists. And then every once in a while, maybe you'll have an angle that's a part of a triangle. You can also always remember that 3 angles of a triangle equal 180 degrees. So, how we're actually going to use this, okay? And this is where sometimes there's more than one right way to get to the answer. So when I looked at this figure, my original figure, were these 3 lines all cut by this transversal and labeled with these measurements: 3x plus 5 degrees, 4x plus 35 degrees, and 65 degrees. So it's all about finding a relationship that you could use, okay? And there are a few different ones. So one relationship that I could use was alternate exterior angles. So when I looked, and I know that this is my transversal, and I'm looking at 3x plus 5 and 65. Well, that makes this the interior, because that's the space between the 2 lines, and this the transversal. So these are alternate exterior angles because they're on different sides of the transversal and they're both outside the lines that created them. So since I was given that M and N were parallel, okay, maybe I'll just mark those just to be sure. I can use the fact that now they have a relationship. So alternate exterior angles when lines were parallel are congruent. That's why I set 3x plus 5 equal to 65, and then I solved. And again, when I substitute x in for 20, I do get 65, so those angles are congruent, and that's how it should have worked out. I also had another set of angles, same side exterior angles. So if I'm looking at 4x plus 35 and 65, here's my transversal. They're both on the same side of the transversal. These are the lines that make up those 2 angles. So this space right here is the interior. For that angle pair, this little space here is the interior. They're both exterior. So I know that same side exterior angles are supplementary. So that's 4x plus 35 plus 65 equals 180. When I solve that, I still get x equals 20, which I should, because this is one figure, so x should kind of be the same no matter what. When I substitute 20 in this time around up here, then I still do get 115 degrees, which when I add that to 65 actually is 180. So with any variable, once I plug it in, it should still work out. So I had a choice in this case of which relationship I used. And just a little side note, I can't really use these 3x plus 5 and 4x plus 35 because they're on different sides of the transversal, because one's over here and one's over there. And then if I'm looking at these 2 angles, this space here is my interior. Well, one is now exterior and one is interior. So I would have 2 angle pairs on different sides of the transversal. One interior, one exterior, that's no angle pair. So I couldn't use those directly like that where they are. Looking at this next figure, all angle pairs have to share the same transversal. And if they have to have a relationship, they have to be built on parallel lines. So the reason why I set this up as 40 plus y plus 80 equals 180 is because I had to look at this whole angle here and 80. These angles right here, 40 and y, have no relationship that I could use because I don't know the degree measure of this whole entire angle. I can't just use y and 80 because even though they share the same transversal right here, the other 2 lines that create those angles are not parallel, so they don't have a relationship that I could use. I cannot use 80 and 40 because even though these lines here are parallel, they do not share a transversal. If I look at 80 and 40, there's no shared piece. And if they don't share a transversal, they have no relationship whatsoever. But if I look at this transversal here and the parallel lines here, this angle here and this whole angle here are my same side interior angles, and that's the supplementary relationship. Then I get y equals 60. Okay. Lastly, I have a quadrilateral, okay? It's telling me that these two sides here are parallel. So again, I still have the relationship of any of those angles that are created by parallel lines cut by a transversal, because I have parallel lines here. This is a transversal. This is also a transversal. So if I look here, these are same side interior angles. They're both on the same side of this transversal between the parallel lines. So same side interior angles are supplementary. So I just added 2x plus x minus 12 and set it equal to 180 and solved for x. I did the same thing over here. This is the transversal. This time they're on the same side of this transversal, still in the interior. So this angle here, 3y, plus this whole angle, y plus 20, equals 180. And then I solved. Again, once I solved for my variable, I plugged it in, and I did get that I would have supplementary relationships. This plus this does equal 180, and as does these two here. So basically, it's all about finding what kind of angle pair that you have based on where they are relative to the transversal and whether they're interior or exterior. This can be a little bit complicated, so please do not hesitate to email questions. Let us know on a Google Hangout that you want to meet. Don't go without getting your questions answered one way or another. So we are here to help, and hopefully we will hear from you soon. Thank you.